All right, guys, so what we're going to be looking at here is the 2015 parametric equations. This is number 2, so you do get to use a calculator from the BC exam. And again, much like other parametric equation problems, I feel like this one's pretty straightforward. So let's just go ahead, dive in, and take a look at this problem. So the introduction to the problem says a particle moving along the curve in the xy plane has the position x of t and y of t with velocity vector. So we were given a velocity vector here. Then at time equals 1, the position of the particle is at the point 3,5. So I have an initial position as well. Now don't forget, anytime we are looking at one of these problems, we have to realize that the x and y coordinates act independently of each other, and there are just some formulas that we use to tie them together. So the first one says find the x coordinate of the position of the particle at time equals 2. Well, in order to do that, we're just going to take all of the x stuff that we have. We're going to take my initial condition plus the integral of when that occurs to the time that I want to know the x coordinate at, and go cosine of t squared dt. So I just put that into my calculator. When I do that, I get 2.557 or 0.556, either way. And that's it. That's all you have to do for letter A. Letter B wants to know there's a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? Well, remember, when we're talking about parametric equations, well, really any equation, our slope of our tangent line is given by dy dx, but because this is a parametric equation and we don't have dy dx, we have to put dy dt over dx dt. So in this case, we have dy dt over dx dt, so I'm going to have e to the 0.5 t over cosine of t squared, and it wants to know when that slope is going to equal 2. Well, in order to do that, we just get our calculator out and we find out where this graph, so this y1 and y2 cross each other. You can use x instead of t. It works the same way, and you should get 0.840 for letter B. Letter C wants to know, find the time in which the speed of the particle is 3. Well, again, this is more or less just checking to see if you know the definition of speed, which is dx dt squared. So I go cosine of t squared plus dy dt squared, e to the 0.5 t squared. And then, so that's our speed equation. We just set that equal to 3. Once we do that, and again, the only mistake I really see people make on this, they accidentally plug in 3 instead of setting it equal to 3, because I want to know when the speed is 3, not the speed at time equals 3. So when we do that, and we just, again, solve it the same way we did letter B, I get 2.196, or 0.95, is your correct answer for letter C. Letter D wants to know the total distance traveled by the particle from time equals 0 to time equals 1. Well, total distance traveled, the formula there is the integral from A to B of the speed function that we just barely did. So I get cosine t squared plus e to the 0.5 t squared. And we just put that into our calculator. And when we do that, we get 1.595, which is the correct answer for letter D. Just like most of these parametric equation problems, as long as you know the definitions, they're very, very simple because you just set it up and plug it into your calculator. All we had to know in this one was speed, slope of the tangent line, and total distance traveled formulas, and you basically got all the problems right. So if you have any questions on this or any of the other problems, please let me know.